All right, so we were up on the slope here, the sand dune, and we had a brunasolic soil. In other places around here, we've also found regosols, but now we're going to walk down from this jack pine stand into this stand down here, which is this transition zone between this upland soil and this wetland soil. And we start moving into some black spruce, and so you're going to be really excited to see this next pit because it is just fascinating. All right, this is a fascinating pit, and I discovered this pit by accident when I started doing this class, the 480 field course. I was traveling around northern Saskatchewan, and I was driving around with my wife in the bush, and I stopped here at this site and thought, I'm going to check this out. Took an auger and came down to this transition area, and I started augering away and found these beautiful dark reddish soils, even black in some places. And I thought I was onto something, and so I dug it, and this is the result of this beautiful colored soil here, which we'll talk about in a minute. But right now, it's filled with water, so I got to clean it out so we can have a look at it. And I kind of leave this bucket in here all the time, but it was fairly full when we got here today. And I'm sure it will continue to seep in because of that wetland area just over there. If you look at the colors on the side of this pit, you see some really deep reds, even some black in some places. And so all of a sudden you got to start thinking of a different kind of soil order that we usually don't find in Saskatchewan. Let's talk about this pit because it is fascinating looking at this pit, and I've got a few surprises in here for you. First of all, we have this forest floor right here, about 5 centimeters thick. Again, this is a more humus form, lifts right off of the mineral soil. And here we have our AE horizon, which is about 20 centimeters thick, and then it starts getting redder in color and grading into about here. And so this could be a BM, maybe a BMJ since it's juvenile. And then below that, we start getting into this really red color and very dense. And I would call this a BF. And then as we get down here, you're not going to believe this, but it's very hard. And I almost have to use a crowbar to break some of this stuff off because it's so cemented. And in the classification system, a cemented horizon is designated by a CC. And here are some examples of these clumps that I have taken out of there. But I think once we get down to this, about 50 centimeters is where the cementation starts happening. And so I think this is a B, and it's very darker in color. There's a spot over here on this side of the pit where it's almost black. And so I would actually call this a BHF with a CC that it's cemented. And down below somewhere is our sea horizon. And unfortunately, because there's so much water in the pit, I can't get to the sea horizon. But so just in summary again, we have this nice AE horizon here, this BM juvenile, a BF, and then a BHF that's cemented down below, and then somewhere down below, it might even be closer to 100 centimeters as we get into our sea horizon. And so for me, this classifies out as a podzol. And a very, very interesting podzol. I'll have to get my classification book out and we'll talk about that for a minute. Let's talk about the classification for this soil because podzols aren't very common here in Saskatchewan. There are typically 3 great groups. There's the humic podzol, the ferric humic podzol, or the humic ferric podzol. And to do this, you need chemical data. And actually, because I've been doing this for such a long time, I've actually had these horizons analyzed in the lab, particularly for organic carbon and pyrophosphate extractable iron and aluminum. And if we look at these BF horizon, the BHF horizon, we're dealing with about 1.8% carbon. And the extractable pyrophosphate iron and aluminum has to be more than 0.4% for sands. And then again, this is a very sandy soil, a fine sand, and we ended up being over 0.4%. So I think this is a humoferric podzol. And because we've got this compacted cemented layer at about 50 centimeters, I would call this an Ortstein humic ferric podzol. So let's just do a summary of this profile again. And I have taken some samples from the pit and put them on this booklet, which will give you an idea of what we're dealing with. When looking at these different samples, the surface here we have this AE horizon, which is about 0 to 20. This BM juvenile, which is down to 30 centimeters. And then we have our BF horizon. You notice this really intense red color. And this goes down to about 50 horizons. And then at 50 you get this cemented, really hard layer. You can see these particles here that I've dug up from there. And I would call this a BHF because it's very dark in color, a lot of organic aluminum, iron in it. And this area here actually comes from the other side of the pit, but very, very black. Just to talk about a little bit about the vegetation at this site, we are predominantly here in this transition zone with a lot of black spruce. And after I've gone through the key, there's more than 25% black spruce. And this turns out to be a BP Boreal Plains 14, which is a black spruce Labrador tea feather moss site on a very moist sandy clay loam soil. I don't think there's any clay loam here because this is a very sandy soil. I've got water in the bottom of the pit, so there's a lot of seepage going on here as well. And then if you think about the drainage, it's probably anywhere from imperfect to okay, because there have been years where I haven't seen any water in the bottom of this pit. But at the moment, there is water here, so I would say the drainage is kind of imperfect, although it's very hard to tell if we got any modeling going on here. So again, a very, very interesting soil, one of the most unique soils that I've seen here in the province. And then now we're going to go move down to the lower depressional area here, and we're going to see again something very, very interesting.